compute the integral going from 0 to 2 x e to the x squared dx. First, notice this integral is a definite integral going from 0 to 2, and notice we cannot integrate that function straight away. This is a complex function, so we want to check if U substitution applies in here. If it does, then there's two methods to apply U substitution in case of definite integral. In the first method, first I'm gonna find the indefinite integral, and then I'm gonna use U substitution and then integrate and back substitute the function of U, and then lastly apply the fundamental theorem of calculus. On the second method, first I'm gonna use U substitution, that's including the limits, and then so I'm gonna write the limit of the integral in term of U, and then I'm gonna integrate using the fundamental theorem of calculus. So let's start with the first method. Again, first I want to find the indefinite integral. Here, I'm gonna check if U substitution applies first. So I'm gonna look into that function, and then I'm gonna look into a term inside that function, and if the derivative of that term also exists on the same function. Notice in here, when we take the derivative of x squared, gonna be equal to 2x. Notice that 2x is actually in the same function. Therefore, the inside function gonna be x squared. So the first step, I'm gonna make the U substitution. So U gonna be equal to the inside function, and du gonna be equal to 2x dx. Note in here that we only have x dx in the top integral, so I'm gonna move to the other side. Now step 2, I'm gonna integrate after I make the U substitution. So I'm gonna arrange this term, I'm gonna bring x in the front of dx. Notice that x dx gonna be equal to 1 over 2 du, and then x squared, this is equal to u from step number 1. Therefore, this is gonna be equal to the integral of e to the u half of du. Then I'm gonna pull half out of the integral since it's constant, and we are left with the integral of e du. Notice this is a way simpler function that we know the integral of. It's gonna just be e du plus c. Now the third step is back substitute the function of u, which is x squared. Now the fourth step is to use the fundamental theorem of calculus. So notice this is the top integral gonna be equal to half e x squared, which is antiderivative evaluated at the limits of the integral, which is 0 and 2. Now I'm gonna evaluate 0 and 2 and e to the x squared. This is going to be equal to half e to the 4 minus 1, and that is our solution. Now I'm gonna apply the second method. So straight away I'm gonna jump to U substitution. Here we already know from the first method that u gonna be equal to x squared, and du gonna be equal to 2x dx, and then I'm gonna move 2 to the other side. Gonna be half du equal to x dx. Now I'm gonna find the limits of the integral of x in terms of u. So the limit are 0 and 2. So in terms of x equal to 0, u is 0. In terms of x equal to 2, u gonna be equal to 2 squared, which equal to 4. Now let's integrate and use the fundamental theorem of calculus. So this is the top integral. Now I'm gonna arrange these terms. I'm gonna bring x next to dx. Notice that x dx is half du and x squared is u, and the new limit of the integral gonna be equal to 0 and 4. Now I'm gonna move half out of the integral since it's constant, and we'll left off with the definite integral from 0 to 4 e to the u du. Now let's integrate. That's gonna be half e to the u, then evaluated at 0 and 4. That's gonna be equal to half, and then e to the 4 minus e to the 0. And this is gonna be exactly the same thing we found from the first method. For me, I prefer using the second method, so I'm gonna use the second method in the following examples. Part 2. Compute the definite integral from 0 to pi over 4 of tan cubed theta over cosine square of theta d theta. Notice this is a complex function. We cannot just integrate it right away, so I'm gonna check if your substitution applies. I'm gonna look to the integrand function, and I'm gonna look into a term and check if the derivative of that term also exists on the same function. Notice in here, when I'm take the derivative of tan of theta, it's going to be equal to 1 over cosine square of theta. And 1 over cosine of theta is also exists on the same function. Therefore, u substitution applies in here, and then the inside function is going to be equal to tan of theta. So the first step, u gonna be equal to tan of theta, and then du gonna be equal to 1 over cosine square of theta d theta. Now for the limits, for theta here we have 0 and pi over 4. We want to write them in term of u. In case of 0, u gonna be equal to tan of 0, which is gonna be equal to 0. Now in case of theta is equal to pi over 4, you're gonna be equal to tan of pi over 4, which is gonna be equal to 1. Now, before integration using the FTC, I'm gonna arrange the terms. So I'm gonna bring 1 over cosine square of theta next to d theta. Now you can notice it clearly that this term is du from the last step, and then tan of theta is u. Notice in here, tan cubed of theta can be written as tan of theta all cubed. This term gonna be equal to u cubed. This gonna be equal to the integral of the new limit 0 and 1 of u cubed and then just du. You can notice now it's a way simpler to integrate. The integral gonna be just be 1 over 4 u to the 4 and then evaluated at 0 and 1. This is gonna be 1 over 4 and then evaluation gonna be 1 over 4 minus 0 over 4, which just gonna be equal to 1 over 4. Part 3. Compute the definite integral from 1 to 3 1 over 5 minus x dx. Here let's check if your substitution applies. When we integrate the bottom function 5 minus x, it's going to be equal to minus 1. And 1 it's already exists on the same function. Therefore use substitution apply. The inside function and the first step gonna be equal to 5 minus x. du gonna be equal to minus 1 dx. Now we only have 1 dx, so I'm gonna move the minus sign to the other side. Now in the limits we have 1 and 3. We want to write these in terms of u. So if x equal to 1, u gonna be equal to 5 minus 1, which equal to 4. And then in case of x equal to 3, u gonna be equal to 5 minus 3, which equal to 2. Now Step 2 is to integrate using the fundamental theorem of calculus. This is going to be equal to the integral with the new limit, which is going from 4 to 2, and then 1 dx is just equal to minus du from step number 1, and then 5 minus x is just u. Now this is a way simpler integrand. I'm gonna pull the minus sign out of the integral. Now let's integrate and use the fundamental theorem of calculus. This is going to be equal to minus the natural log of u, and then evaluate it at the limits of the integral. This is going to be equal to minus the natural log of the absolute value of 2 minus the natural log of the absolute value of 4. Now I'm going to multiply the minus sign inside the parentheses. That's going to be natural log of the absolute value of 4 minus natural log of the absolute value of 2. Now 4 and 2 are positive number, so we can get rid of the absolute value. Now using the natural log properties, this is going to be equal to the natural log of 4 over 2, and then 4 over 2 is just equal to 2. Part 4, compute the definite integral from 1 to 4 of e to the square root of x over the square root of x dx. Here we cannot integrate this function right away, so let's check if substitution applies in here. What I'm going to do, I'm going to take the square root of x, I'm going to take the derivative of that. Notice this square root of x is going to just be equal to x to the power of half. Now we already take the derivative. It's going to be half x to minus half, which equal to half 1 over square root of x. Notice that 1 over square root of x is already exists on the function. Therefore, use substitution works in here. And the inside function is going to be equal to the square root of x in the first step. Now, du going to be equal to half, and then 1 over square root of x, and then dx. Notice in the top, the given integral is just square root of x dx, so I'm going to move the half to the other side. So it's going to be 2 du equal to 1 over the square root of x dx. Now, on the limits, let's write these in term of u. Here x is going to be equal to 1 and 4. In term of x equal to 1, u going to be equal to square root of 1. And in term of x equal to 4, u going to be equal to 2. Now, for step 2, I'm going to integrate using the fundamental theorem of calculus. This is just the top integral. I'm going to do some arranging here. So what I'm going to do, I'm going to bring 1 over square root of x next the dx. Now we can see that this term going to be equal to 2 du, and then the square root of x is just u. So the integral is going to be with the new limits. It's going to be going from 1 to 2 of e to the u, and then 2 du. Now I'm going to pull 2 out of the integral since it's just a constant. Now we are ready to integrate. Going to be equal to 2, then e to the u, then evaluate it at the limit of the integral. It's going to be 2 multiplied by e to the 2 minus e to the 1. And that is the answer for the definite integral. Notice in here, when we are using the u substitution, remember that u of x is going to be equal to the inside function. This is a tip. It's not always correct, but it's usually correct. That inside function gonna usually be inside of square root, or it's gonna be the exponent for e, or we are giving a fraction, it's gonna be the denominator. Again, this is usually the case, not always.